Hi everybody, thank you for coming this evening. My name is Gina Wallace and I have put evaluations out for you and would appreciate your comments and evaluating my speech. This evening I will be talking about a few forensic investigation processes, or in TV terms, CSI Aurora starring Gina. The first CSI topics I will be discussing are determining the time and cause of death, DNA, hair, and fiber. The research and information for these subjects was gathered from the J. Siegel and Kathy Merkowitz book written in 2010, Forensic Science, The Basics. The last topic I'm going to cover is fingerprints, and my source of information for prints is from the book Crime Scene Investigation written in 2011 by Jacqueline Fish, Larry Miller, and Michael Broswell. I would like to start by talking about estimating the time and cause of death. In criminal investigations, these estimations are rarely an exact science. The cause of death is derived in many different ways, such as examination of the crime scene, looking for weapons, blood patterns, bullets, and evidence. Also talking with witnesses, if any, and any pictures or videos documenting the crime are helpful. Gathering the information on the deceased is one of the most important strategies of law enforcement agents. Interviews can help investigators with questions like when the victim was last seen, who he was seen with, who he talked to, or are there any rumors? Another indicator can be the type of wound, if there is one. A cut or straight line can mean a knife or sharp object. A roundish entry hole along with an exit wound can mean a shooting. The coroner and medical examiner can also give their opinions, and then the autopsy and toxicology report usually will reveal the cause of death. Estimating the time of death can be difficult as well. There are a few clues agents use, such as blood pooling, which is when the blood pulls in the deceased body to the downside, and this happens within the first hour, and then the blood will remain in that same spot, possibly indicating to the investigators when the body died or when the victim died, or if the body was moved. Bloating can also give an idea of the time of death. A body will start bloating within the first day and then will unbloat, releasing the fluids and pressure within 3 to 4 days. In some cases, they use entomology, which is insects. Insects are commonly attracted to dead bodies, and entomologists can figure the time of death based on the stages of the bug's life. The most important indicator for the time of death is the timeline of the deceased. Where they were found dead, who found them, and like I said, when they were last seen alive. Estimating the time of death is just that, an estimation, and is not an exact science, as I said before. Next, I will be talking about trace evidence. Hair and fibers, as well as glass and paint, are considered to be trace evidence. Only general information can be obtained about this type of evidence, such as their material, type, size, color, where they were manufactured, and any specifics such as distributor, suppliers, or availability, like if they're rare or foreign. This is why trace evidence is considered to be subjective and is sometimes called class evidence by investigators. And here's a couple samples of some hair and fiber you can pass around. Hair and fibers is not thought of as solid proof, and it is unlikely that they will hold up in a court of law these days. Most of the time, investigators just use hair and fibers or trace evidence to help with leads or their investigation. The fibers are tested to figure out what kind they are, whether they're natural, synthetic, or semi-synthetic. Investigators analyze magnified fibers to view their type whether they're carpet or rope, and whether they are crimped, twisted, straight, or are multi-stranded. They will also test the fibers for delucerance and their refractive index. As for the hair, investigators can only determine if the hair is human or animal. With animal hair, they can identify the type of animal that the hair belongs to. Hair is analyzed through a microscope, and it's identified by the shaft characteristics, the medulla, the cuticle, the cortex, and the pigmentation. If the hair was plucked out and not cut, the follicle end of the hair may have DNA. DNA typing was started in the 1980s with the first method used called RFLP, which stands for Restriction Fragment Length Polymorphism. RFLP was done by using a gel tray with grooves. The DNA is separated by enzymes and placed into the tray where it will travel through the grooves. The smaller particles traveling farther than the larger particles, resulting in short repeating units. This method of DNA typing was not reliable because it required a large sample quantity of DNA. And this is some DNA pictures. The method Later in the 1980s, analysis came up with a DNA process called PCR, which is polymerase chain reaction. PCRs duplicate single-strand DNA through a heat-controlled process, and the DNA is then amplified by enzymes within a thermal cycler. This process is done using very small or micro samples of DNA, making it more reliable. The most recent process is now STRs, which stands for short tandem repeats. Used with the PCRs and the RFLPs, this method detects repeating patterns in the DNA strands. The patterns are based on a specific set of 13 loci, or alleles, that are different in all people. Once the DNA is identified, it is run through a database system developed in the 1990s called CODIS, which stands for Combined DNA Index System. Once run through the database, if there is any matching DNA results, it will return them to indicate the match. The discovery of DNA typing has enabled possible convictions, several jail releases, and presented evidence of guilt or innocence in many cases. More than 99% of human DNA is identical, leaving less than 1% to differentiate us. DNA typing is a crucial tool for investigators, with the one downfall being that DNA is the same in identical twins. However, their fingerprints will not match, and this leads me to my next topic of fingerprints. Our fingerprint ridges begin to form while we are in the womb at about 6 months, and they never change throughout our lifetime. The main reason we develop the friction ridges in our fingers, hands, and feet are for gripping. Everyone in the world has different ridge patterns, and no two are the same, even in identical twins, as I mentioned. Prints are caused by skin producing oils and moistures, enabling the ridges to leave an impression. The impression can be left on various items and through thin gloves, paper, and other porous materials. Investigators can usually pull prints off smooth surfaces, such as glass, plastic, walls, weapons, and furniture, taking these impressions with powder, ink, or digital scanners. Once taken, the next step is for the print is to figure out the print types. The three main types of prints classified in the 1890s by Sir Francis Dalton are loops, whorls, and arches. Within each type are different categories, such as a tenon arch, double loop, or accidental roll. The most common type of print is a loop, with about 60% of the population having this kind. That's a sample of the print types. Loop prints have a delta or core, and the loop will face towards either the thumb or the pinky. The roll print makes up of approximately 35% of the population, also has a delta, and the ridges are in an enclosed spiral formation. The third type of print is an arch. These do not have a delta or core, and only 5% of the population have this kind. Arch prints have a continuous smooth line of friction ridges going from one side of the finger to the other. When the print type has been determined, it is then examined for a set of specific identifying points, such as islands, splitting ridges, bifurcations, dots, ending ridges, short ridges, and the delta. The identifiers are then reviewed and marked by numerous professionals. After marked, the print is then fed into the FBI's database system that was created in 1999 called the Integrated Automated Fingerprint Identification System, or IAFIS. Here's some examples of the identifying characteristics. Whether there is a match for the prints or no match, it can take the computer days or weeks to return any results, much longer than what TV leads us to believe. Throughout history, people, usually criminals, have attempted to remove or alter their fingerprints. Some of the ways people have tried to do this are by burning them off, dipping their fingerprints in acid, or by slicing or removing their fingertip skin. It is not recommended that you try any of these for obvious reasons, and also because in most cases they make a fingerprint more identifiable and unique. One method known to work is coating the fingertip with super glue, filling in the ridge patterns and disguising the print. And when I get finished, so you know, I have up here some cards and some ink pads so you can take your print to see if you can identify its type and the characteristics. And then for my conclusion, the topics I have gone over are a small sample of the various methods and fields involved with forensic science and criminal investigation. In addition to these topics that I discussed, DNA, fingerprints, hair fibers, and depth estimation, there are many other processes, types, subfields, and tasks involved with forensic science. The jobs and careers in criminal investigation are numerous and widespread throughout the world. These major jobs include crime lab technician, forensic pathologist, forensic engineer, odontology, forensic anthropologist, and behavioral forensic science. Jobs can range from small towns where one person is responsible for many tasks to large cities like Denver, where one task is done by several people. Crime scene investigations and forensic science and all their arenas rely on each other to be successful. They both involve many different pieces that must be put together like a puzzle. The final product or goal being a solved crime or investigation. And that will conclude my speech for this evening. Thank you for coming out. I hope you enjoyed it.
Woo-hoo.